Hey makers, how are you doing? RoboPapa here. And today what I want to do is build on top of what we did and build last week. I'll leave a card probably somewhere over here for you to watch it if you missed it. So we will build on top of last week. Just what we're going to do now is adding a little bit more sensors to show how things working, and we'll use Visuino as well again. So let me give you a sneak peek over here. So what we'll have is a crystal LCD over here, so we can show the text as well as the values of the components or the sensors. We'll use the same encoder from last week. I added ambient light sensor as well as a photoresistor sensor, as well as humidity and temperature sensor. All of this together, we'll use the Visuino to basically program the Arduino. In a nutshell, the decoder will decide which sensor we're going to show on the display, and only that text will show on those two lines. So I think the best way is to get started and show you how all of this is done. So let's jump into the computer. Okay, guys, so I have Visuino open over here. So let's start designing how the code will look like. So we know we need a encoder, and we have basically three sensors: the photoresistor, the TEMP 6000. I'll leave a link for that ambient light in the description below, as well as the humidity and temperature. And all of that will be pushed to a crystal display, two-line crystal display. So let's start by actually bringing the encoder. And this is what we did also last week. And if you missed it, once again, I'll leave a card somewhere, for you to be able to follow. So we know that the clock is going to pin 9. So we'll carry pin 9. And the direction goes to pin 10. Okay. So now what we need to do is also set up the each value, how long or how far is the encoder going to look like. So we're going to put the min and max, and I'm sorry that I need to shrink this. It's just that I have an overlay of the recording over here. I don't know if it shows on the video, but I had to move this. So let's remove the rotation, so it will not rotate, and we'll put the maximum value as 3, the minimum value as 0, and it's not rotating as well. So, okay, so that means that the encoder will be able to go from 0 to 3. So now we need to make a decision in here. So what we want to bring is a demuxer. And let me click away from this. And we need, I believe it's, a clock demuxer. And the clock demuxer will have 3 outputs. And the input will be selected from the pin itself. So from the encoder value. Each of these outputs will tell what sensor we actually want to read. Oops, I'm sorry, this is not going to here, it's actually going to here. Now, in order for us not to flood this whole system, we will want to run it on a clock. So if we take a clock, and it will just clock generator, and we'll use this clock to run the other components. So we will actually bring it out to here. Okay, so the next component that we know, and let me push it a little bit because we will need that space. The next component that we know that we will need is the crystal. So we look at the display, and we don't want the I2C. We just want the regular crystal. And the way I connected the crystal is that the register select goes to pin 7. So if I'll move it over here, so here's pin 7. The enable goes to 6. And then the datas are going to be from 5 to 2. Data 1, 2, so 0 to 3. Okay. And I know that we will want 2 lines. So the way I found to actually have the crystal output 2 different lines is by adding 2 text fields to it. So text field 1, text field 2. And that will allow me to output line over here and line over here. So let me see if there's anything else we need to do. So this is column, row. Yes. Then 16 columns. I think that the elements, we have 2 elements. So the first, so you can see the first element, column 0, row 0. The second element needs to be column 0, row 2, row 1. Okay. And that's how they should be able to actually recognize. Let me move this again. If we have the elements, you can see them over here. So column 0, row 0, that's where it will start to write this. And then the next element will be column 0, row 1. Okay. So now we have the crystal over here. So now we need to start actually bringing all the different outputs, etc. So let's start with our humidity. And it's right this one. Okay. So we have the humidity sensor, and the humidity sensor pin over here, you can see it's in red circle. That means it's a required, and it will go to pin number 8. Where is my pin number 8? Yes. Sorry, I'm looking at the connections that I have. And these two will be basically our outputs. So the outputs themselves, we will need to have text in them. So the first line will be just a regular text. And where are you? Over here. Text value. Here we go. So this will be my header. So, and you can see that I need a clock, and that's why I was talking about the clocks will be important over here. So first, let's do the value of that, and we can do temperature / humidity. That's the output of this text, and this will go into my inputs right over here. Then we need a format text, and we'll put a right over here. And the format text will need to have two inputs that are analog. 1, 2. There we go. So the first one will be my temperature. My second one will be my humidity. And the output will be here. And the output of this is %0 is the temperature / %1. So with the text format, the %0, %1, %2, etc. are actually the inputs of all of your values. So now let's say that I'm on with the encoder, I'm on the beginning, so value 0. So I know that this pin will be high. So I can actually take that and say, hey, you are high, and therefore I want you to work on all of these inputs and outputs. So that will initialize and run all of this. And therefore it will read the values from this sensor and output the text here. So the next thing that we want to do now is the other two sensors we have are really photoresistors, and they are coming from our analog outputs. So basically A0 and A1. But those will actually go into a text as well. So if you think about it, we will need the text value. So we'll do the same thing, text value. Here we are. So this is my one header, and here's my second header for my second sensor. So this one goes here, and this one goes here. And the value for these, or the outputs, so they will come with the first line. These two will come also for the first line because they are the header or the first line that I want to output. So this will be, we'll call it a photo resistor, and this will be PMT 6000. I believe that's the sensor. That's PEMT 6000. So when the encoder is on pin 1 or value 1, pin 1 will be high, and therefore those will be running. Otherwise, it will go for the other ones. So the other thing that we want is now format a text. And we'll put it here. This is 1. This is 2. Once again, the output from here will need to be the clock for this one. And the output from this one will be the clock of this. And we will want to have we will want to have, I believe, an analog element for this. Yes. We'll want to have an analog element for this. Yes. Yeah, we will want an analog element. Cool. Let me let me zoom out so we can actually move this a little bit. text. And if you know like a better way to do it, definitely leave a comment below. This is just how I found a way to do it. And then this outputs from here will go to the second line. And the output from this one will go to the second line. Okay. And the format will be 0. And the format for this one will be %0. So now we need to bring the analog. But if we think about it, the analog value will be between 0 and 1. And I would like to place that as a percentage. So all we need to do is to take that and multiply by 100. So what we want is multiply by, I think, or multiply, let's see, an analog. I believe this one. No. Hmm. Analog by value. Here we go. So we want this for the first element. And that one will be, let's see, what is the text output for this one? That will be a 1. So analog 1 output. And the output of that will be the input for this one. And we just want to multiply by 100. So now if we copy this, then I'm just pressing Control C, Control V, and we'll do the same thing for this one, except that we'll need to change the pin. So if we disconnect this, and we go to pin 0, okay. All right, so we have one sensor goes with the output, the second sensor go to the output. We have our third sensor, which is the humidity, goes to the output. And now we'll just need to connect the clocks of these values with this clock. So we'll go from clock here, there, clock there, there. And I believe that should be everything that we need to connect. Yeah. So once again, just to recap, the encoder over here will make a decision, which will pass it to the demuxer. The demuxer itself will basically, depending on the pin, which is on the select over here, will set if it's high or low. And these pins are basically the clock for each sensor and the output that we need to go into the crystal. And according to that pin, that is what sensors we actually will show. So let's build this, and we'll push it to the Arduino. So we'll build this, and let me set up the camera over here. All right, so the camera is actually on, and you can see over here that we have temperature and humidity. And if you cannot see, there we go. So you can see temperature and humidity. And if I switch with the encoder here, you can see that it's changing the sensor. And if I'll continue, it will not do anything. Now it's the temperature and humidity for the resistor temperature. There you go, guys. And you can see like the photoresistor is right over here on the side. If I press it, there's less light. I remove my finger, suddenly there's more light. So that's it, guys. That's how you can actually use Visuino with multiple sensors. I know it looks a little bit convoluted over here, maybe, or compact. Just that my screen is very small. If you like that, please give me a thumbs up, and don't forget to subscribe and press the bell button for notification. If you have any questions or comments, leave them below. I read every comment and try to answer for everyone. And yeah, let me know what you guys thought about this. How would you use all these sensors in your project? How could you do this better? I'm sure that it can be done in a much better way. So please comment below so everyone can learn from it. Until next time, guys. Bye.